And the web viewer portion is the part of Communicator that is running on the client's machine that is going to, in most cases, be doing the actual rendering of the data. Now, there's a number of things that go into the client, and the main thing is that it's going to receive the data that is streamed from the server. So if we go ahead and show this video, we can see here that the data is coming in chunks, and what this does is it makes it so we don't have to load the entire file at once when we go to view it. So for a lot of models that are on the smaller side, loading the entire model doesn't take a lot of time. But you can imagine for very large, complex assemblies, such as buildings or entire cars, that loading all that data is going to take a significant amount of time. And with Communicator and the web viewer in particular, the goal here is the shortest possible time to first interaction with the model. So we saw in the video that the camera was moving while the model was still streaming in. And that's sort of the interactive streaming of data. Now, a little bit more about the viewer. So we support basically desktop and mobile, and we support most modern browsers. So when we say modern browsers, they need to obviously support WebGL, because that's what we're using to do the rendering, and they need to support WebSockets. So most browsers these days have those out of the box. I believe IE 11 is the lowest version of IE that we support, but all of the big guys work fine. Now, the main thing, aside from the rendering that the web viewer is doing, is this integration of business logic. And we have an example for this we'll do a little bit later. But what integration of business logic means is tying in additional metadata that your application has about or to the relevant part of the model. For example, so we have this motorbike up here. Say we're a machine shop or not a machine shop, a distributor that maintains an inventory of all these different parts. So people may need to order replacement spokes or tires or something along those lines. So maybe in our system we say, okay, we know we have 30 tires in stock, and we want to create an application that the user can hover over or click on a part and see how many are in stock. So the web viewer provides the ability for us to integrate this external logic with the graphics display. We're going to look more at that later, but just know that that's one of the big things that customers use the viewer for, is linking up that data and then representing it in the 3D window. A little bit more to say. So the user interface is completely customizable. What this means is that we're not tied to a specific toolkit. You may have heard of like jQuery or other toolkits like that. We don't require or use any of those. Basically, at its heart, Communicator's web viewer is just the 3D window. You can put things on top of it, next to it, around it, however you want to style it, but we don't impose any restrictions on that. So, the way it works is you design your interface around Communicator and then use our API to drive the interactions. I mean, you can have buttons that would change colors or anything like that is possible with the UI. And then finally, a biggie here, we'll look again, we have an example on this, is the custom operator support. So if you're familiar with HPS at all, they have the concept of operators, and our concept of operators are similar. An operator is just a class that you write that has a number of methods on it that are called when certain things happen. So for example, maybe you want to do something where as you mouse over different parts, it changes them to pink or something. You would write a custom operator that would receive mouse events from our system, and then you can, see what part your mouse is over and then change the color. So the operators provide hooks into the input that's processed by the system to allow you to drive interactions. So anything from like clicks or mouse overs or mouse out of the window or anything along those lines, you can hook into with your custom operator and then make calls into the Communicator API. So it just allows you to extend the functionality of the viewer to your own needs. Okay, so let's talk a little bit more about how the viewer receives the data from the client, from the server, sorry. So there's 3 different ways to stream the data. So the one we've been talking about and the default way is interactive. Now, if you think back to that video, you saw like things kind of popped in as time went on. Now, the interactive mode comprises of 2 separate, let's just say, schemes of sending the data. So the first scheme and the most overarching scheme is what you can see. So as we pan the camera, that camera position is continuously sent to the server, and that server is receiving that, and then it knows where everything in the scene is located. And it's going to say, okay, here's the 10 objects the client can see right now, send that off down. And it's constantly reevaluating that list of objects that can be seen. Along with that, we also then take that list of things that you can see and then sort it by size. So we're going to send the largest things that you can see down first. And if you notice in that motorbike, the large side panels would pop in first, then the tires, and the spokes will kind of come in last, because we want people to kind of get a good idea of what they're working with by sending the largest ones first. Now, in tandem with the the graphics data, which is what we've mostly been talking about, we're also streaming down the model tree data as well. So we kind of interleave that so that the model tree data comes down along with the graphics data. So that's the interactive mode. Now, that's all well and good, but there are some caveats to that, which are addressed by the all mode. So you may think, okay, what if I never look at the trash can? Will it ever be streamed down? Well, no, it won't. But like maybe I don't want to keep all these resources alive on the server, right? Because if you think back to the diagram, every client had a supporting server process. And you can imagine with a lot of users, that can become a burden on your server. Each one of those processes is taking up some memory and some processor time and things like that. So maybe for some models that aren't that big, we can just send the whole thing down. We want to stream the whole thing down. And that's where all mode comes in. So with all mode, it will send all of the data from the file that it's viewing down to the client. That being said, we're still going to use those same 2 schemes from the interactive mode, being what can I see and what are the biggest things. The difference is that that's just a priority. So, for example, if I'm looking here, I can see the tables, I can see the chairs, I can't see the trash can. Once it streams down all the tables and chairs, it's still going to stream down that trash can now, unlike interactive mode. But it will prioritize the necessary data first. So then, with all mode, once everything is streamed down, we'll give you a callback that says, hey, I'm done. And then you can, if you want, you can then kill this process on the server so that you can free up those resources. Now, you don't always want to kill that process, and we'll talk a little bit more about that later, but think of all mode as a way to just stream the data down to the client, prioritizing what they can see first, and then when it's done, you can just hang up that connection. Now, the third mode is on demand. So, on demand is pretty much completely separate from the first two modes. And on-demand mode essentially sends nothing. So all it does is load the file. You can spin the camera all you want, it's not going to send anything. What it will do is it will wait for you to tell it what to load. I need to actually start that over, but anyways, it sends down the model data. It doesn't send any graphics data. It will send down the model tree data. On-demand sends no graphics data, but it will send the model data. And the reason for this is that you can then specify the nodes or IDs that you want to see. So, for example, maybe you have a building and there's a node for each floor, and you want to load floor 5. So you can say, get that node ID for the parent of node for everything in floor 5 and say, stream this, and it will stream that node's ID and all children of it down to the client. So the idea here is that, say you have a very large building and maybe it's too much for like a Chromebook to handle, and you want people to be able to view maybe one floor of this building on their Chromebook. You can say, okay, I'm not going to load anything except for floor 5, and they won't have to pay the overhead of rendering the entire building. And likewise, if all you want is floor 5 out of the model, you can say on-demand loading, load floor 5, and then hang up that connection, which will release those resources on the server. So the idea here is that the web viewer is very flexible in terms of how to get the data in. And we found that these 3 streaming modes pretty much handle all of the use cases that we've had from customers. And I'll save the demonstration for a bit later when we kind of dive into the package. But that's pretty much the getting the data into the viewer. Okay. So now that we have the data in, we want to do stuff with the data. So, like I mentioned, we support both desktop and mobile devices. So, on desktop, you're going to be using a mouse. On mobile, we support all touch events. So, if you're writing your own operators, you can hook into those touch events as well. The main thing, or one of the main things that you're going to want to do is select parts. And we have all of our selection, we have a default selection scheme that's included with Communicator. You can select on parts, lines, and faces, or entire nodes. So you can set the granularity of the selection that you want. And there's a callback that you hook into for this selection. So we'll take a look at that when we kind of dive into the exercises. But we give you back a callback that has like sort of the node ID of what you selected, and then if you selected on face or line, the ID of the corresponding line. You can also set some selection properties, like if you only want to select lines, only want to select faces, only want to select points, we let you do that as well. So the idea is that you don't have to write your own selection operator. You can use ours and then hook into the callback for that. You can resize the canvas and reposition it as you want. There's an API method you have to call every time you move it, but we can resize and move. So if you want it to kind of come in from the top or slide in from the side, all that's supported. And then we'll talk a little bit about the SSR now. So the idea behind the SSR is for very large models that won't fit into when I say don't fit, maybe your target devices don't have the power to render such a large model. And we can use the server-side rendering to do that rendering on the server, and we only will send down images to the client. So, for example, think of it as like the client in this case becomes a dumb terminal. It simply is processing inputs and then essentially sending some commands to the server where all that's done. All the logic and heavy lifting is done with the server. The problem with the SSR is that shifts the burden of rendering from all of your clients, which is essentially their hardware, to your hardware. And you're going to have to back that with graphics device. So that's the disadvantage there. Okay, so this shows an example of how we can reskin the viewer, so to speak. So on the left-hand side there, we have our default UI, and then on the right-hand side, we have a different UI. So you can see we could change the background color, we can sort of float all these things on top of the viewer. So really, like I mentioned earlier, all you're getting from the viewer is a 3D window, and you can do anything you want on top of that 3D window.